Okay, so now we reach to application framework, that component which most of the applications interact directly. And this application framework contains
Sorry for interrupting you once
three major
again.
components.
Your voice is again
Yes,
very low, and people are unable to hear
very
you.
low, is it?
Now all of the sudden it has become good.
Can you hear me now?
Yeah, it's better now.
Can you hear me now?
Yeah, it's much
Okay,
better.
great.
Thanks.
Okay. So in application framework we have many components. One of the very important component of application framework is activity manager. This is the component which actually manages life cycle of the applications and gives us a common backstack for navigation. So we are going to look more deeper into this in further slides. We have got package manager, which essentially holds information about various applications loaded in the system. At times, applications may need information about other applications, and package manager is going to help us in that. We have got something like resource manager, which gives us access to non-code resources such as localized strings or various other, we can have layouts. So many resources we can have in the form of PNG, BMP as well as XML. So resource manager helps us to get access to those non-code resources. We have got content provider, which is extremely important component of application framework. This gives us access to the data from other applications, for example contacts, or to share their own data. As we discussed briefly earlier, that every application is running in its own process. So one application does not have access to the process area of another application. But if they want to exchange data among each other, they can achieve it through content providers. We have got notification manager, which helps us to display custom alerts on status bar. This notification manager is primarily important in case of broadcast receivers. We are going to look at what is a broadcast receiver. So it helps us to display various kinds of alerts on status manager. We have something like location managers, which handles information about the location. And we have telephony manager, which handles information about telephony, which is again, yes, if it is using GSM telephony or some other kind of telephony, there is some dependency on the hardware. So these are the core services which are provided by application framework. Apart from this, there are some more services which need hardware support. For example, you want Bluetooth service, you want Wi-Fi service, USB service, or any sensor. So all these things become hardware dependent. Okay, so now we have reached to application layers. As we already saw, Android ships with a set of core applications, for example, contacts, calendar, or maybe email, SMS, browser. We already had a look. And most of the application developers code sits here with other core applications. And the key thing, even Google applications use the same public API that is available for open developer community. And all applications in this layer are written using Java. So we have seen we can have Java source code, and we can have resources which can be in XML, PNG, etc. I'm not sure how clear this slide is to you. I will try to speak it as clear as possible so that you understand how do we reach to an application. An application in Android is nothing but an .apk file. So finally when we compile and build our source code, we get an .apk file which contains the whole application package. So how that API gets generated? When we start application development, we have got Java source file and we have got our resources, which are non-code resources. The Java source file passes through a Java compiler and gives us an output as .class files, standard Java application development process. Then these .class files are given as an input to DX tool, which gives us .dex files. Then we have got a tool called AAPT, which is nothing but application asset packaging tool, which takes .dex file as well as these XML and PNG and packs it into an APK. And finally, this is an APK file which gets installed on mobile devices. So this briefs how we convert our source code or resources into a final APK file which gets installed on a mobile device. We have talked about like all applications in Android are treated equal, whether these are core applications or non-core applications. Then if they are treated equal, it seems obvious that security is a concern. That if every application has a similar privilege, then every application can damage the other application. So once an application is installed on a device, each application actually lives in its own security sandbox. So that's a way to achieve security for Android. So Android is actually based on multi-user Linux system in which each application is a different user. And by default, the system assigns each application a unique Linux user ID. Each application is having its own user ID, own process, and each process has got its own virtual machine or DVM. So essentially, by default, every application runs in its own Linux process. So Android just starts the process when any of the application component needs to be executed. In the coming slides, we are going to look at various components of an application. But the idea here to understand is, as soon as Android starts the process, whenever any of the components needs to be executed, and when that component is no longer needed, it just shuts it down. So that's how Android manages its security. Okay, we have looked at application layer, we have looked at how security is achieved in an application. Now we are going to look at what are the various application components which help us to come up with an application. So these are the 4 components in an application. The foremost important one is an activity, which is nothing but a screen on a UI which you can see in the mobile device. You can actually instantiate an activity from any other activity or screen. And if you want to do it, if you really look at the UI of any mobile device, you get one screen, or you have a home application or home screen. You press some soft key or hard key, it gives you another screen. So that screen is nothing but an activity in case of Android. And when you want to switch from one screen to another screen or one activity to another activity, Android uses a mechanism of messaging which is called intent and intent filters. Intent and intent filters, which help us to move from one screen to other screen. We are going to look at these intents and intent filters in the upcoming slides. So idea here to use intent and intent filters. Then we have something called services, which are long-lived and they run without UI. So it's possible for you to connect to or in Android terms bind to an ongoing service and just start the service if it is not already running. So if you have got a background service, you can bind to it, or if you want to start it afresh, you can start it. And once you are connected to a service, you can seamlessly communicate with the service through the interfaces, whatever the service exposes. There is something called content providers, which is used to store or update or retrieve data. So this data is generally stored in file system or SQLite database, and it's extremely useful for sharing big chunks of data across applications. Content provider actually, when we are looking out from an application point of view, we do not applications do not talk to content provider directly. They actually talk to content resolver, an entity called content resolver, and content resolver can talk to any content provider. So whenever there is a content provider, it implements a standard set of methods that enable various applications to retrieve or store the data. But how applications really do it? They invoke content resolver APIs, and then content resolver talks to content provider to achieve the required functionality. Earlier in the session, we were talking about broadcast receivers. This is the last component of an application, but equally important whenever you want to react to an external event. To take an example, let's say you get an incoming call on your mobile phone and you want to do something extra than the default application whenever a call comes. So you got to register broadcast receiver. So whenever the phone ring comes, or have any UI. But you can use the application framework. You can use the notification manager to alert the user. So your update may come in the status bar at top of the mobile phone, showing the current status update. Okay, so we have seen what are the of now we are do we activate the thing about start activity, start service, or broadcast intent, which helps us to activate various components. So start activity, as the name itself signifies, is to launch an activity. Start service, or we can also have bind service. Whenever you want to communicate with a background service, and broadcast and receiver component. So, and in case of content provider, the fourth component, we already saw that we need to call content resolver API to connect to content provider. So there is no activation as such required for a content provider. So when we pass these intents to these functions like start activity or start service, what kind of information is carried in it? It carries an action which tells what general action needs to be performed. For example, if you are trying to make a call, you may give an action call, or if you want to edit a document, you may say action edit. So what general action needs to be performed? The second thing is on what data this action has to be performed. So action and data are actually paired. So the different kind of actions are paired with different kind of data. For example, if your action is action edit, your data field should contain a document which has to be displayed for editing. Another information carried in intent is category, which contains additional information about the kind of component that should handle the event. So this category tells which kind of component can handle the event. For example, you have a hyperlink. Your category may be category browsable, which can tell you what kind of component can handle it. Then it carries something called the component, which is the class name, in case you want to pass an intent to a specific component. For example, you are in activity A and you want to start activity B. So you already know the component name of activity B. You can just specify the component name there and activity B will be invoked directly. So if you specify the component name, Android system does not need to check intent filter like which activity has to be launched. It can directly invoke the component which is explicitly specified. If we don't specify this component explicitly, Android system is going to decide based on action, data and category which component should be launched. Then we can also bundle some extra information in the form of key value pair along with an intent. We just talked briefly in the last slide about the component name. What happens if we specify the component name or if we don't specify the component name? So there are essentially two kinds of intents, explicit intent and an implicit intent. Explicit intent in which we designate the target component. We specify the component name, and in that case nothing specific is required. Android system just launches that component. But in case of implicit intents, we do not name the target, and Android system must find the best component or a number of components. In case Android system finds more than one component, then Android system may give this option to the end user by listing all the components and let the user choose and decide which component he or she would like to launch. So how Android system resolves that? Android system compares the content of intent object against intent filters. So whenever my application wants to listen to a specific intent, I need to define an intent filter in a file which is called AndroidManifest.xml. We are going to look at that file also in coming slides. And this file helps Android system to compare the intent object and decide which all components can handle this intent. But when this comparison is being done, only three aspects are consulted: action, data and category. So it does not take care of component name anyway, because if component name is there, it becomes an explicit intent, and it does not take care of even extras or other field when this comparison is being done. So what are intent filters? Intent filters are a mechanism to inform the Android system which implicit intents they would like to handle. So if my application wants to listen for phone ring, maybe I have to, or let's say my application would like to know when the phone is booted completely, I have to mention it in my intent filter. So activities, services, and broadcast receivers can have more than intent filters, obviously, as they may be interested to listen more than one intents. And these intent filters are set up in application's manifest file, which is called as AndroidManifest.xml as intent filter elements. So an intent filter has fields that parallel the action, data, and category fields of an intent object. So whenever an intent object is created, this data is fed in, and the same data is mentioned in intent filter. If Android system compares and finds them to be same, it makes out that this component can handle this intent. And there are some, we have talked about action, data, and category. There are some special action and category, like special action is main and the special category is launcher. Whenever you have an activity in your application which needs to be launcher for your application. For example, you have an application with 4 activities A, B, C, and D, and you want whenever your application gets launched, activity B should be launched first. Then activity B may flow to other activities. So you got to have an intent filter which specifies for this activity action as main and category as launcher. Based on this, Android system knows this is the first activity which has to be launched. This is the manifest file we talked about. It is must for each application, and the name must be kept same, and the name should be AndroidManifest.xml. The purpose of this manifest file is to present essential information to the Android system, like this names the Java package for the application. It describes various components of the application. It declares the permissions application must have to interact with other applications. So this is another new concept of permissions. If my application wants to have an access to context database, I must ask for this permission in AndroidManifest.xml. Advantage of this permission is when my application gets installed, Android system is going to show the list of these permissions to the end user during installation, which makes the end user aware all these permissions are required by this application, and end user may choose to install or not to install this application if he sees any risk in installing the application. In case end user sees application is asking for a permission which is not really required, end user may choose not to install that application. Then in this file you need to declare the permissions that others are required to have in case they want to use your application. This is a brief about application resources, which can be like images, audio files, etc. The layouts of the activity. You can have various kinds of layout of an activity like linear layouts, relative layouts. So your default UI is saved in, let's say if you are talking about layout, and if you look at an application source code, resources are present in a folder res, and the layouts of that application are present in res/layout directory. So all these XMLs will lie in this directory. So advantage of keeping these resources separately is you can update application characteristics without modifying the code. And you can have alternative resources for a variety of different configurations. For example, you want different resources when your device is in landscape mode, and you want different resources when your device is in portrait mode. So you can keep different set of resources in respective folders, and Android system is going to decide, is going to pick up the resources accordingly. Okay, we understood about various application components. Here I have picked up home application launch. The idea of picking up home application is because this will tell us what all is happening under the hood. So bootloader first thing loads the Linux kernel and starts the process. So the first thing which comes into picture is init process. So init process starts our Linux daemons, all the daemons like USB daemon for your USB connections, or in case you have telephony support, the real daemon is going to come in picture. And an important daemon is, very important daemon is Android debug bridge. Then it starts a zygote process, which is a nascent process which actually initiates each DVM instance. It starts a runtime process, which actually initializes and registers something called service manager, which becomes our default context manager for handling various services. For various services, what we have talked in our application framework, like activity manager, package manager, etc. So as we saw, the runtime process is started. Then runtime process sends a request for zygote to start the same process. And since this is also a separate process, so zygote forks a new VM instance for the system server process and starts service. The system service starts the application framework services, for example, activity
So,
manager.
once again, the
So after the
voice is
system
very low.
server loads, hello,
Once again, the
hello,
voice is very low now.
is it is it audible now?
Yeah, yeah, it's better now.
Okay,
Yeah.
I'll be a little louder.
Okay, fine.
So after system server loads all the services, Zygo creates home application in a separate process, and subsequent applications are launched in their own process. So we will now understand this in the next diagram, which tells how this is really happening. So we have our init process, which starts the daemon processes, the runtime process, and zygote process. Zygote process starts the system server with separate Dalvik VM, and in turn all the services, activity manager, package manager, etc. And then it launches the home application. So home application becomes our first application. Any application launched after that is coming on top of that. So this home application launch helps us to understand the whole flow, what is happening inside when any application or process is getting launched. So this is a brief about Android development, what are various applications. So I would like to open this forum now for the questions. If you have any questions, please.